All right, example 3. What is the fifth root of 16 times the fifth root of 8 in reduced radical form? Now this one actually asks for radical form. Radical form means that there's going to be a radicals object in the answer. In this case, we deal with fifth roots, so it'll be a fifth root. First thing I want to bring to your attention is the roots are the same, fifth and fifth. If this were a fifth root, this were a fourth root, it's a little bit more challenging. And I can't guarantee they're going to be the same every time, so I'm going to go ahead and pretend they aren't, because the technique I'm going to show you works every single time. Whereas if we did it just because they're the same, there's another way to do this one particularly. But in general, what I'm looking at here is I've got 16 to a fifth root and 8 to a fifth root. First thing I notice is 16 and 8 are both powers of 2. 2 times 2 is 4, times 2 is 8, so that's 2 cubed, times another 2 is 16, that's 2 to the 4th. The fact that those are the same number is useful. If I couldn't get them to be the same number, it wouldn't be useful. All right? But the fact that they are the same number, again, it's useful, so I'm going to go ahead and do it. If this said 9 and this said 16, that's 3 times 3, that's 2 times 2 times 2 times 2. This step would be pointless. All right, next, I can see that I got a fifth root and a fifth root, so I'm going to change these to fractional powers. So this is going to be 2 to the 4 over 5 power, being multiplied by 2 to the 3 over 5 power. So again, just making a fractional power, the power divided by the root makes the fractional power. Power divided by root. We've created a structure just like example 1 now, right? We have a number to a power, sometimes the same number to a power. The numbers match. So we're going to get the product by rewriting the base 2, and we're going to add 4/5 and 3/5, make 7/5. If these roots were different, we would have uncommon denominators there. We'd have to create common denominators to add those. Now, looking at 7/5, that is an improper fraction. What's the mixed number version of 7/5?
1 and 2/5.
7/5 is 1 and 2/5, right? If you don't recall how to do that, you take the denominator into the numerator. Remainder's 2, the remainder goes over the divisor. So 2 over 5, 1 and 2/5, right? So, consider that 1 and 2/5 is just 1 plus 2/5, so 2 to the 7/5 is just 2 to the 1st times 2 to the 2/5. Again, it wants reduced radical form, wants a radical structure. It wants it simplified as much as possible. So you need to pull out anything you can pull out. Well, the fact we have 2 to the 1st power, that means a whole number of 2 is part of the answer. We have a 2 to the 2/5 power, which means a fifth root of 2 squared is inside. And notice, instead of writing 2 squared, I wrote 4, right? 2 squared is 2 times 2, which is 4.
Mr. Klein, on the very first, is that 2 and 7/5 or 2 and 2/5?
This one here?
No, down.
Right here?
Yeah.
That's 2 to the 7/5.
Okay.
Can you start writing bigger?
No, I just couldn't see it because of the line.
Okay, all right. 2 to the 7 over 5, yep. So, again, reduced radical form means that anything can be pulled out is pulled out, anything that can't be pulled out is to stay in, and you want, it's just a regular number. So 2 outside, 2 squared, which is 4 inside. That's what we're looking for in an answer like that.